Hi, my name is Madalina Bulat, and I'm an undergraduate student majoring in computer science. I started participating in research my sophomore year, and I'm extremely grateful to be able to continue conducting it. One of my research projects involves how individuals detect deepfakes using artificial intelligence. This presentation is based on a research study conducted in previous semesters, as well as a paper that was written and submitted for the 2024 iConference meeting. Deepfakes can refer to information, a fact, an object, or a digital artifact that has been manipulated convincingly using technology. Deepfakes are a specific manipulation technique where people digitally alter, modify, or replace images or videos with the intention to change people's perception of reality. For this research project, we tackled the question of how whether or not users can detect computer-manipulated images through a series of surveys and questionnaires, and also whether these users trusted the images that they saw. We looked at something called the interpersonal deception theory, which is a communication theory that attempts to understand how individuals handle real and sometimes perceived deception at the interpersonal level. The theory breaks down the deceptive process and explains tactics employed, such as falsification, where information is forged or invented, concealment, where truthful elements are taken out, and equivocation, where vague information is used to mislead. The result of these altered images could be that they make us question whether or not what we see and hear is real. This doubt can affect public discussions and the trustworthiness of evidence that are presented in media. Software that detects deepfake images typically works by analyzing the content of an image or video to look for inconsistencies that are not usually present in natural images. Deepfake technology uses artificial intelligence and machine learning algorithms, particularly generative adversarial networks, to create realistic-looking images and videos by superimposing existing images and videos onto source content. To combat these advanced manipulations, deepfake detection software utilizes a few different methods, such as machine learning models, which are trained on datasets containing both real and deepfake images. The model learns to differentiate between the two by recognizing patterns and features that are indicative of deepfakes. Another one would be analysis of physical inconsistencies. Deepfakes often contain physical inconsistencies that can be a giveaway. For example, the blinking of eyes in videos might be unnatural, or the lighting and shadows may not correspond to the environment. And lastly, biometric analysis. This involves looking at the finer details of human biology, such as the way the skin pores and heartbeat and blood flow affect the appearance of a face. Deepfakes often fail to replace these subtle details accurately. In an effort to understand and counteract this, our research team has been working with an innovative piece of software known as Veracity AI. It's currently under development at the School of Information with the generous support of Dr. Shoyan Metcalf. The essence of Veracity AI lies in its ability to detect manipulated images. Specifically, Veracity AI is a prototype for deepfake imagery analysis using deep learning models trained to detect splicing, inpainting, and copy move manipulations. These techniques are the backbone of what we now commonly refer to as deepfake technology. Splicing involves taking portions of one image and grafting them onto another, creating a new composite image that appears to be a single, unaltered photograph. Inpainting is a digital restoration process. It is a way to fill in missing or unwanted parts of an image. It can be used to remove elements from a picture, such as wires, signs, or even people, and fill in the background as if they were never there. With deep learning algorithms, inpainting is now capable of generating pixels that match the surrounding area. Lastly, copy move manipulation is a technique where parts of an image are copied and pasted within the same image, often used to cover up elements or to clone objects. This method can be exploited to create more of something that was less of, such as crowds, or to fabricate scenes by duplicating elements within that scene. The early stages of Veracity AI used something called the ensemble method, where it showed the manipulated parts of the image through color coordination. The parts of the image that were manipulated were in black, while the parts that were authentic were in white. Gray corresponded to undetermined. As you can see in the image above, the ensemble method was used to show what parts of the image were manipulated, but also work on sound and video, and this will make it better at spotting and dealing with deepfakes in a more complete way. Thank you.